Conference, your source for JVM knowledge.
Okay, so I think we're just going to get the intros out of the way because we have a hard stop at 6 o'clock, I believe. So let's get as much done so that we can get time for Q&A and all those fun things at the end. So in this talk, I'm going to give a little status update on Grails 4. On the progress there, we are towards releasing Grails 4 in GA form. The subtext of this is bringing Micronaut goodness to Grails. And you'll see why in a moment. I don't need to do the intro because I imagine everybody here was in my previous talk, so we can skip that. So we'll do a little bit of an intro to Micronaut. I'm sure that most of you already know what it is. Talk about a comparison to Grails. Grails versus Micronaut. When would you use what when? Using Micronaut features in Grails, and then we'll do a little round of demos, which should be fun, as always. So in terms of Micronaut as a Grails developer, Micronaut for me is a foundational library for building applications of any type. So although the name Micronaut, obviously it's directing you towards the fact that it's optimized for microservices and the micro part of Micronaut, I guess. But fundamentally, it's a set of building blocks for building applications, Java applications. Anything with a static void main is a potential Micronaut application. And it does so but through focusing on small memory footprint and speed. And in order to achieve small memory footprint and speed, and the true innovation in Micronaut, which is really driving all of the interest in Micronaut and seeing organizations like Red Hat and Pivotal really try and focus on performance, is the fact that Micronaut has eliminated reflection, runtime proxies, and runtime analysis from the stacks. So this has completely changed the way architecturally traditional server-side Java applications are built. And Micronaut is really an industry-changing technology that is doing a lot to push Java forward in terms of making more optimal applications for the server side. So Micronaut, as I said, it uses no reflection, no runtime proxies, no runtime bytecode generation. So we don't use ByteBuddy, we don't use cglib, we don't use anything that may produce or consume memory at runtime. Everything is done using ahead-of-time compilation at compilation time. And this is really what has allowed us to achieve the low memory footprint that Micronaut has in comparison to your traditional frameworks. Because fundamentally reflection, like I said in my previous talk, consumes memory. And it's kind of uncontrolled memory because you can't really control as a framework developer, if the framework relies on reflection, you can't really control when and how reflection is used unless you compute it ahead of time. So we reduce all of that, and all of these aspects mean it's increasing. They're increasingly important for certain use cases. So microservices, obviously, serverless functions, cold starts, but also other applications. For example, IoT. If you're going to run Micronaut on a low memory footprint device, such as a Raspberry Pi or something like that, we have Micronaut in one of our demos where we demo Micronaut service discovery. We have essentially a rack of little Raspberry Pis that running Micronaut apps. So you have this low memory footprint environment that Micronaut is promoting. And now if you look at that in comparison to Grails, so Micronaut is really it has a range of runtimes. It's not specific to any one runtime. So for example, you can write Kafka message-driven microservices. You can write traditional kind of REST APIs. There's a whole different ways you can use Micronaut, whilst Grails is a servlet-only environment. Micronaut is general purpose. So whether you are building whatever type of application you're building, we have even a team internally at OCI that are using Micronaut to build a Swing application. So you can use it for anything. It's completely general purpose, while obviously Grails is focused on traditional servlet web apps. Micronaut includes DI, AOP, configuration management, all those things that you get in a traditional framework, but all computed at compilation time. Grails very much relies on Spring, since it's historically been built on Spring for those services. And Micronaut, you can write a Micronaut app in Java, Kotlin, Groovy, or Graal VM native. We have a choice of languages, whilst Grails is very much focused on the Groovy space. Micronaut can be used as a client or a server. So you can write client-side libraries with Micronaut or server applications, while Grails is very much a server component. So in terms of Grails 4, what's new in Grails 4? So Grails 4, we really had to wait for a lot of libraries to catch up to a Java 8 baseline, because the first requirement was we wanted to go Java 8 only. We had to wait for things like Groovy 2.5 to catch up with the changes around Java 8 and Spring 5 and so forth. So because fundamentally Grails is like a layer on top of these existing frameworks. One of the big things that were in Grails 4 is just the fact that we've managed finally to get everything updated and working with the latest versions of Java 8, Spring 5.1, Spring Boot 2.1, Groovy 2.5, and Hibernate 5.4 and Gradle 5. This was no small amount of effort, trust me. It was challenging to get all these. And part of that was a whole legacy cleanup activity, which enabled us to reduce startup time and memory consumption. So the reduction in startup time and memory consumption comes from two key changes in in Grails 4. Sorry, one is because of Micronaut, the Pivotal team have finally taken startup time seriously. There are improvements in Spring Boot 2.1, which means that Spring Boot itself is faster to start up. Grails 4 being built on Boot obviously benefits from those. And of course, we've also rebased a lot of the internals of Grails on top of Micronaut using the Micronaut integration. So Micronaut has become essentially the parent application context. And I'll discuss this in a minute for all Grails 4 applications. So the current status of Grails 4 is that we released a milestone 2 on Tuesday. We're still gathering feedback and issue reports from the community. The Grails, obviously, one of the big things about Grails is the massive amount of plugins that we've always historically had. And the community is testing those plugins and providing us feedback, and we're fixing things and reiterating. Most major plugins appear to be already operational. I think there's still some issues around Spring Security, but there's a snapshot that works with Spring Security. And we're migrating all the guides, all of the tutorials, all of the documentation, and everything, upgrading it to Grails 4. Ideally, we would like to start, like RC soon, and ideally a GA, around a month or just over. But it's very much based on what kind of feedback we get from the community and so forth. The good news is that the upgrade from Grails 3 to 4 is nowhere near as difficult as the upgrade from Grails 2 to 3. So that's good news for a lot of people, because the upgrade from Grails 2 to 3, we know from hearing feedback, that was a significant one, which required a lot of changes. The upgrade from Grails 3 to 4 is actually a much simpler upgrade. Once we got all the plugins working and so forth, it will be pretty much seamless for most users. There are obviously changes in the underlying frameworks. Each one, Spring Boot 2.1 has its own list of changes. Hibernate has its own changes, and so forth. But fundamentally, it should be a much simpler upgrade to get from Grails 3 to Grails 4, which is good news for those folks looking and excited to upgrade. Speaking of folks looking excited to upgrade, we did a webinar on Grails 4 a few days ago, and we had 600 people attend the webinar, which is a massive amount of people for a webinar. For us, that's pretty awesome. There's a lot of pent-up interest in seeing where Grails 4 goes, and we're excited about it, and the community are as well. So it's a good time to start looking at it and reporting feedback to the Grails issues tracker. So in terms of Grails 4 and Micronaut, what we've done is Micronaut is very small and very fast to start up. So we've set up Micronaut as the parent application context of Grails. So Grails is essentially Spring underneath. Historically, it has been Spring underneath. So Spring supports this notion of application context hierarchies, where you can have a parent context and a child context, and it'll try and look up, when it looks up a bean, it'll try and look up a bean from first the child, and if it's not found, it'll look up in the parent and traverse up the hierarchy to search for beans. What we've done is we've made an adapt interface that adapts Spring to Micronaut such that you can register Micronaut as the parent context. And it's not something specific to Grails. It's actually in this sub-project here. You can use it if you have a normal Spring app. You can plug it in. You can say, when you boot up your Spring Boot app, you can say set parent context Micronaut, and you can use Micronaut as your parent context. It's cool because Micronaut libraries become usable in Grails and also Spring. So if you have a Spring Boot app, you can use it. And because Micronaut is like I said, compilation-free, there's no reflection, there's no runtime bytecode generation. It increases, if you're using like Spring Boot, for example, increases your chance of getting operational on something like GraalVM. And it's also cool because anything we build for Micronaut also benefits the Grails community. And that's really where we're trying to get to. We don't want to build Grails plugins anymore that only benefit Groovy users. We want to build Micronaut features that benefit Groovy users, the Java community, and the Kotlin community, and the whole of JVM. So that's what we're trying to achieve with Micronaut. So what can and should you do? Grails has had a plugin system for, Grails has been around for over 10 years now, and it's had a plugin system in that whole time. And over the years, the plugin system has become less and less used. In the first versions of Grails, plugins provided like build plugin. They were like build plugins, and they were runtime plugins, and they were plugins did everything. And then when we moved to Grails 3, Gradle replaced a lot of the build plugins, so the build plugins went away, and Spring Boot replaced many of the runtime plugins through auto configurations. So plugins are less necessary than they used to be, and what we're going to be doing in the future is we're going to be building Micronaut configurations instead of plugins where possible. And also in your Grails 4 applications, the declarative clients within Micronaut will become the official supported solutions for all of those things. So Micronaut has the declarative clients for HTTP, for Kafka, for RabbitMQ, and there's a whole bunch of more integrations coming. So they'll essentially be automatically working in Grails 4 applications. So configurations versus plugins, you should consider building, as I said, configurations instead of plugins. They work with Micronaut, Spring, or Grails, and whilst a plugin will only work with Grails. And there are some things that are not possible with Grails, with anything but a Grails plugin. For example, with a Grails plugin, you can provide like views and GSP, server-side views and tag libraries and certain things related to GSP. But most people are using Vue or Angular or something like that on the front end nowadays. So is it really necessary to provide those things? And for only maybe a subset of plugins that actually exist. Micronaut configurations also provide all of the features that Grails plugin developers have been accustomed to be able to do. Because one of the, way before Spring Boot came up with auto configurations, Grails plugins were doing all of that, convention over configuration and auto configuration and so forth. And Micronaut configurations have all those benefits of Spring Boot ones and Grails plugins, but without the kind of runtime overhead of reflection or anything like that. So you can define, configuration properties, beans, singleton. You can do conditional behavior, what that requires. You can customize the context with that replaces. There's a whole bunch of stuff that you can do. So here's an example of configuration properties. You can define a class that's just an example configuration, then it's bound to the example namespace. And then when you run your app, the value of the name property there will be, in this case, demo. And it's type safe configuration binding. And it works reflection free. The objects are created without reflection, bound without reflection, and it just works a whole lot better. So traditionally in Grails plugins, there was like programmatic logic to read the configuration from like a map, which is a lot more error prone. And this one, in this case, you can define like validation rules with javax.validation. So you can say the string is at not blank, and it will be validated when it loads. So there's a lot more options available to you with configuration properties. And then for conditional logic, you can define conditional logic with that requires. So it already supports, it's a repeatable annotation that you can repeat multiple times. And it already supports a whole bunch of options. So you can say at requires property, and this bean will only be loaded when example.enabled is set. You can say at requires bean, and this bean will only be loaded if another bean of type data source is present. You can say at requires missing beans equals example, and it will only be loaded if there's not another implementation of this bean. You can say at requires condition equals some custom class, and do your own custom conditions. And with all these conditions, the computation and even if you reference a class that's not on the class path, so I say at requires beans classes equals data source, and data source for some reason is not on the class path, Micronaut does not do any dynamic class loading to work that out. It doesn't, at least not with class.forName or anything like that. It's computing all that information statically when you build your application, so there's no runtime craziness going on. And yeah, you can run the app and implement whatever conditions that you want. So that requires is very powerful. One of the things I really did not like about Spring was the concept of bean names. So in Spring, every bean has a unique name. And the way it works is auto configurations have to kind of depend on each other, and they depend on load order. So you can have one configuration that defines one bean called foo of type bar, and another configuration that defines another bean of type foo equals, that is of type baz. And depending on load order, one can overwrite the other, and it's kind of random of which one is the actual type. So one of the things I really wanted to get rid of in the design of Micronaut was the notion of bean names. So in Micronaut, there's no bean names. You can replace, and any replacement, any bean replacement, when you want to replace an existing bean, is declared up front. So so you can enable logging to figure out exactly which beans are being replaced, and it's very clear about what's happening, instead of like this notion of the order of the loading of beans and having to load after and load before and a mess. So so that was at replaces allows you to replace a bean with a different type. You can also declare a bean as at infrastructure, which means that it cannot be replaced. So if there's an important bean that you don't want end users replacing, you can say, hey, this is infrastructure, don't do it, and then it's not replaceable, so that users don't do crazy things. And yeah, you can. It's very, very flexible system. And then we have the clients. So we have decorative compile time clients. So you can define in Micronaut, you can define an interface, and the interface is implemented for you at compilation time. So instead of like creating a runtime proxy and using a reflection to delegate underneath. At compilation time, we implement the interface for you. And it's really fast since there's no reflection, and they load very quickly. It supports this. This is a blocking example, so it's returning an info object of type, but you can return RxJava or Reactor or Future. It's completely reflection and runtime proxy free. This is a little example of a GitHub client. You can add it to your Grails 4 application just by adding that dependency. And there's a low-level client under the surface. If you don't want to use a decorative approach and you want to do something more programmatic, you can inject that instead. It's built with Micronaut AOP. It works with Grail native image, integrates nicely with tracing, metrics, and service discovery, and it's completely usable inside of a Grails 4 application, which is pretty cool. Same thing with Kafka. So we have a decorative, compile time implemented Kafka client. You just define a Kafka client, you say which topic you want to send it to, the Kafka key. Again, it supports blocking, non-blocking, RxJava, Reactor, Future, whatever you want. The project repository is there, and once again, you just inject it into a Grails app, and you're away. Same with RabbitMQ. Again, you can define compilation time implemented RabbitMQ clients. Just an interface, and it implements all the annoying logic that you don't want to implement of sending the thing and doing the marshalling and everything. So let's do a demo. So I have a Grails app here, Grails 4 app, and it has a single controller, which is a REST controller, and it's just returning a list of books, which is empty right now. And you can see that I'm auto-wiring into it a book configuration, and the book configuration is a Micronaut configuration properties, computed at compilation time, with the name of the publisher. And if you look at my, I'm going to presentation mode. If you look at my application.yaml, I have books.publisher.somepublisher, and that's the value that it will get bound to. Then it's also being injected a Kafka client. The Kafka client is got a single method which just sends the book that's being saved to a particular partition using the Kafka key. And why is that? And why has IntelliJ frozen on me? And in the action here, what it's doing is we have a save method to save the book, and it's setting the publisher property of the book. It's saving the book using Graeme, and it's using the Kafka client. It's sending the book to a Kafka queue. The actual Kafka listener is over here. It's a different Micronaut application written in Groovy, and it's a regular Micronaut application, Kafka application. It's completely headless. There's no HTTP server. It just depends on Kafka, and it just has a kind of static void main to run the application. It has a single listener that's listening to Kafka messages coming in on the same topic, and it has the domain class and so forth, and reads it in, and it's running in the background. I'm actually running it using the cheating way, which is I have dependencies on. You wouldn't do this in production. I have dependencies on the test artifacts for Kafka. So it's running Kafka embedded in the same JVM. In a real production environment, you would configure Kafka to be somewhere else. So this is obviously not a production-ready demo, but it's embedded Kafka. But it's cool that you can embed Kafka, right? That you can embed Kafka right there in the JVM, and Micronaut detects that Kafka test is on the class path and automatically sets up embedded Kafka for you. Don't have to do anything. Yeah. So yeah, it's listening for Kafka messages, and then I have over here a test which is using Micronaut, spinning up Micronaut and retrieving a HTTP client, which is this guy here. And you can see that the client is referencing an ID of books, and that is actually configured in application.yaml as well. And you can have more than one of these, so you could actually load balance in between different books, or you could use console, or you could use Kubernetes, or you could use whatever service discovery mechanism floats your boat, DNS. In this case, I'm hard coding it to a list of fixed URLs. And it's getting hold of a reference to my client, saving the book, which is calling my Grails application, which is saving it using Graeme to the database. And if the demo gods are with me and I run the demo, it passes and it does its thing. I've got trace logging in here, and you can see that it's sending off the request. So I'm not cheating. It's sending the request with Micronaut, and it's receiving the response from the Grails server. And you can see my Kafka listener received the message. And it's a Grails 4 application that's using Micronaut libraries to implement all the important stuff, right? So that's an example of what Grails users are going to be able to do with Grails 4. With Micronaut doing all the heavy lifting in terms of integration with these third-party components like Kafka or RabbitMQ or whatever. So that is the demo. Like I showed you in that demo, you can use Micronaut and Grails together, and a lot of people are doing that. Many people, Grails is fantastic at certain use cases. There's still nothing faster for developing CRUD applications, and they just read right to the database with views, server-side views. And not everybody wants to be doing microservices, and maybe you only want to go partial microservices. So you can start off small and have like Grails still be your main app, and then use Micronaut for your message listeners, your Kafka message listeners, or something like that. Micronaut supports, as I just demonstrated there, message-driven microservices where you don't have a UI, on the, and actually if you add a UI to that message-driven microservice through the HTTP server, it actually has some benefits because you can expose health checks and so forth of HTTP, but it's not a requirement because you may want to health check your Kafka listeners. It can be run, they can be run as a standalone process. We support RabbitMQ, we support Kafka. We'll be supporting more different messaging systems in the future. It's a pretty cool way to start using Micronaut. The Micronaut clients are all compilation time, reflection and runtime proxy free. You can write them in Java, Groovy, or Kotlin, and they're built with Micronaut AOP, which which is ridiculously simple and doesn't use proxy factory beans and crazy things. So, in summary, Micronaut provides an awesome foundation for Grails 4, and we're moving slowly all of the internals of Grails 4 to use Micronaut DI. You'll see a lot of the internals of Grails 4 are using Micronaut DI instead of Spring to improve startup time. Over time, that'll become more and more of the case. And one day in the future, it would be nice if there was like a Grails version of Micronaut, completely without the Spring parts. But that's maybe a longer-term thing. Micronaut is the building blocks to do that, to create libraries, to create configurations. And most Micronaut features are available in Grails and will be available in Grails with Grails 4. And the message here is, build Micronaut libraries, not plugins. So that's that. Before I do the Q&A, we did, following on my last talk, hit 2,000 followers on the Micronaut repo. So we actually now have 2009 followers on our Micronaut repo. And I have 2 t-shirts to give away to the lucky winners. So I was watching the thing, and we're going to go through a list of names, and if that person is here and their GitHub account is active, then you can either choose a Grails shirt or a Micronaut shirt. So the 2000th person to star Micronaut was Rocksteady. Would you like a Micronaut shirt? Yes? Okay. Here you go. Can you catch? Goodness, almost took the ceiling off. Okay. And Sir Gep. Oh my goodness, you two in the corner. Okay. Oh, crap. Why's it back there? Okay. Very good. So yeah. And with that, we have time for some Q&A. Any questions? Yes.
Any feature deprecations?
Yes. So in Grails 3 and below, we had our own REST client called REST Builder. Is deprecated essentially in favor of Micronaut's HTTP client. There are deprecations changes around Graeme. Things like we no longer the biggest change for Graeme users is that we no longer automatically unwrap proxies when you access them. So that is deprecated behavior, and we want something we wanted to change in Graeme 7 because it caused a lot of performance problems. Transactions? Was there?
Transactions are required.
Yes, transactions are required. So in Hibernate 5.3 and above, you must have a transaction present. And that's what JPA insists on as well. And I think we were playing hard and loose before, where sometimes there was not a transaction present and Hibernate didn't complain, and it was kind of in auto commit mode. Now in the latest version of Hibernate, you must always have a transaction present, even if it's a reloading operation. So there's little things like that. But it's not like a major upgrade. And also we deleted everything that was deprecated in Grails 3. So if there is interfaces and stuff. So if there's a plugin or library that's referencing those interfaces, which they shouldn't have been because they've been deprecated for a very long time, then that plugin or library will need updating. So that was part of the legacy cleanup bit. Any other questions? Yes?
If we start using Micronaut features like security features that are implemented in Micronaut inside Grails 4, is that advisable instead of using the Spring security stuff?
No, so a lot of the HTTP part, you'll still be using Spring. What the libraries that you're more going to be interested in using are the client libraries from Micronaut, right? We have to wanted to strike a very fine balance between providing a smooth upgrade for users and integrating as much of Micronaut as possible. Fundamentally, Grails is still based on Spring Boot 2.1. It's still Spring App, and we can't change that without breaking everything. And we don't want to put the same upgrade scenario as the Grails 2 to 3 upgrade on Grails users. I don't think it would be right at this time. So it's going to be a much simpler upgrade, a much easier upgrade, much less problematic upgrade, because we're trying not to break anything. Okay, as much as possible, within reason when things underneath have changed. One other thing that's deprecated is Spring Loaded. We used the JVM agent Spring Loaded in Grails 3 to do automatic reloading. So that is no longer maintained, and it's also only supports Java 8. It doesn't support Java 11, and there was no plans to update it to Java 11. So we have no choice but to remove that. And Grails 4 uses DevTools, Spring Boot's DevTools, which is the same as normal Spring Boot, to do fast restart instead. Huh? And but those are Spring Boot changes. There's a whole bunch of Spring Boot changes, but that's part of Spring Boot. So yeah. Anything else? Yeah.
Well, I kind of know the answer for Grails because it depends on Groovy, so I'll ask for Micronaut. Where's the current state for supporting modules for Java 9 and plus?
So I know that Micronaut works with modules, and we have one colleague in OCI that is doing some modular stuff with Micronaut. You have to say that you export or you have to import the Micronaut modules, and we produce module names for all the Micronaut jars.
So is this auto modules or module descriptors?
It's just auto modules at the moment. But we are not officially supporting that because, frankly, I think that whole effort is almost dead in the water with the movement towards containers and stuff like that. But if somebody is interested in getting that working better, it's certainly worth exploration. I think that I read something interesting about using like module loaders or something where you could maybe spin up the context inside of a module loader or something. But I'm not exactly sure how. But the good news is, I've read the spec and I've read the information and I did some basic tests, and there's nothing in Micronaut that breaks the rules of the module system. So Micronaut generates classes at compilation time, but those classes sit next to your existing classes in the same package.
So no split packages?
So there's no split packages. There's no, it uses service loader to load everything, which is how you do stuff in the module system. So it, in theory, it should work. Should be able to be modular, but we're not like supporting it at the moment, not explicitly anyway. But we do have folks who are playing in that area. Was there a question there? No. Okay, well, thank you very much.